Good afternoon, guys. Welcome to my YouTube channel. My name is Hasan Zeki Alp. You know me. I'm lecturing you courses. This time I will show you Numpy lessons. So far we have broadcast 3 lessons, I think. And this time we'll go on with our Numpy lesson 4. So I'd like to give some example about I use as development environment. I prefer to use Anaconda's Numpy Spyder IDE for integrated development environment. And in our this lesson, I will show you this example. In this example, I'll show you implementation of functions with arguments and showing its values. And here I define a variable here, an array. So I have to include degrees 0, 30, 45, 60 and 90. This is decimal integer, and I would like to calculate the sine of different angles, the signs of these degrees. And before using that, of course I have to I have to convert these decimal values into radians. So this multiplication just does that. This decimal number will be multiplied by pi and divided by 180. So we obtain a radian equivalent, and I will print out the result after calculation, and we'll calculate, of course, cosine of this, and we'll calculate a tangent of this, and all these calculations will be printed in an array manner. So just make it run and see how it is. Okay. Here at the first line, sine of different angles, this is the title for paraphrasing, and it works fine. And 0 and sine of 30 equals to 0.5, you remember, and here corresponds to 45, and sine of 90 equals to 1. And how about cosine? For cosine, the values like this. This corresponds to 1. It's the engineering scientific notation, and this corresponds to actually 0, because 6 points blah 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 to the power of minus 17 corresponds to the possible minus the least minus number. That means 0. Okay, just I can show you the equivalent, the tangent of 45 equals to 1. Okay, just as we expected. And tangent of 0 equals to 0. And how about this pane? In this pane, we can see the current values of our variables. Just we could print out after this calculation, but just this gives an idea about what it does. So I have to show you another example here. Okay, in this example I define an NP array here by importing as NP, and this time I calculate sine, and after that I printed the sine of this one, and this time compute sine inverse of angles. This time by accepting the sine value, I would like to get the radian, the return value as in radian. I mean arc sinus we would like to calculate. and this time I'd like to convert it to degrees. This is the keyword to convert it to degrees. Similarly, just by arc-cosinus or arc-tangent functions behave similarly. Just instead of this, we could use this one, and arc-cosinus for arc-cosinus as well, and this is the same for tangent functions. Okay, instead of saying so lots of words, I have to show it for your eyes. Okay, just before describing, I have to mention this one. Okay. Okay, our initial array is A, and including 5 members, so as to 0, 30, 45, 60, 90, and here I'd like to calculate a sign of this array. So okay, sign values are like this. Okay, okay, just you can see sign values are printed here. Okay, but before printing, I decided to a variable which name is sin. So after this assignment, I prefer it printing. So by using this notation, just you can use this value in other computations. It's different from the previous example. This time I define an invert variable here. Arcsine automatically calculates the corresponding degrees in radians, and this is radian values. Okay, 0 and 0.5 radian and 1.57 radian, and I'd like to convert it to degrees, so I use degrees here. Okay, I get this one after converting to degrees. Okay, and after that arc-cosinus and arc-tangent functions I say behave similarly, so I do that job manually by manipulating multiplying pi and dividing by 180, and like this I get this corresponds to 1, and this corresponds to 0. Okay, and inverse of cosine, there is a ready function for that. Arc cos, this of course inverse of arc cos, we get the same degrees once again as it is expected. How about tangent function? Okay, we are calculating tangent of this one, and of course after that I use the tangent values so as to get the degrees in radians, and after that by changing into degrees I get casual decimal points. And just I'd like to show you the current equivalent values of cosine and sine functions, and just all the things are as summarized here. Once again, I must repeat, we can use ready functions as sign, okay, arc-sine, in order to convert degrees, and or manually we can multiply so as to get in radians, and arc cos, it's gonna get cosine value, numeric value of cosine, so we get degrees, and to convert it to degrees, a degrees function, and tangent tan, and arctangent arctan. That's all. Let's go with our next example. Here I define an array so as to include 5.5. As you see, it contains floating point and decimal point numbers. Print original array. Okay, this is my original array, and after leaving a line, after rounding, I'd like to show you a rounding here. So this is this is done with default values. In this case, decimals would be 1, and in this case, decimals would be -1. So let's make it run and see. Okay. This is the original array. Okay, 1.0, 5.55, 123, and blah blah blah. And after rounding, just look here. After rounding, this is rounding 1 up to 1.6, 123, 1. Okay, it's rounded to 1. And 26, rounded to 26. Okay, how about this example? Decimals equals to 1. Okay, this is 1. Okay, 5.6 decimal part will be decreased, and this is 0.567. So just keeps the decimal part, just we can say, by -1. Okay, 25.532. Okay, it's rounded to 5. However, other part kept as -1. Okay, let's look this one. 0, okay, -1 applied, 10, okay, 120, okay, 0 and 30. Decimal part decrease as -1. Okay, this is another example. Just I prefer to present you. One includes different numbers, minus numbers, and negative numbers and positive numbers. Okay, this is the okay. This is an example for floor rounding. Just when I run this snippet, I can show you. Okay, just when I use floor method, it's decrease so as to get the lowest point. This is initial value, So modified array will be -2, 1.5, -1, 0, and 10. Just I can explain this. It's decreased to the floor, to the bottom value of that number system. Let's go with another example. Here, this time I round the given numbers as ceiling. Ceiling means it's round up to the next decimal point. So when I run this one, okay, I will show you the difference from the other one. Okay, this is the initial array, as you see, and ceiling means it's going to be rounded up to the next decimal. For negative numbers, it must be increased, it must be moved to right. That means -1. So 1.5 becomes 20. 2, and this one also approach to 0, and this one also approach to 1. This also 10 becomes the same. And how about next example? In this example, I define an Numpy array here, so it's gonna get 9. D type will be floating, and I would like to reshape it. So it's gonna have 9 members. So let's run and see step by step how it becomes this snippet. Okay. Okay. This is our first array, so it's to include floating point 0 dot, 1 dot, 2 dot, up to 8. Okay, including 9 members. So in our second array, I define another second array, so as to 10, 10, 10, 3 members. And it's printed, and I'd like to add two arrays. I'd like to two arrays. This is the structure. Add A, B, and after that I print it. Or you prefer it to assign this value one variable, and after that you can print it. For example, add A and B could be, and after that you could prefer to print out A and B variable. And here this is added. As you see, this is our first array. After adding it becomes 10, 11, 12, and 13, 14, 15, and 16, 17, 18. And just similar to this, I could subtract two arrays, multiply and divide by using subtract, multiply and divide. It's so easy. Just you say its English name and the parameters of that arrays, A and B, and just have a look here. Subtract two numbers. Okay, that becomes minus values, and multiply this. You can see here it's multiplied by 10, so it will contain the tens times, folds of tens, and this is the division. After division, you will get a new array. Okay. Let me show you next example. Here I define an array, NP array, such as A, and after printing our original array, I apply reciprocal function here. Reciprocal function means divided by itself. The result will be 1 divided the original number, and I'd like to print out a reciprocal, and I'd like to print out this second array, reciprocal of second array, and this is the title for that. Okay, our array, our initial array, this, okay, you see, and we apply reciprocal. That means 1 divided 0.25. That means 4 in fact. This is gonna be 1 divided 1,333, and this is the same, and just look here, 0 divided 1 divided 0 gives infinity, so there will not be any number here as a result of divided by itself. So 1 divided 100, so it's a decimal notation like this, and after our second array is 100, only contains one member, and after reciprocal function, okay, however, if we say it integer, that means it's may cause an error, because d type is indicated as integer, so divide by 0 will give an infinity, so it's gonna give this result, this warning. And here another example, my array 10, 100, 1000, our array, original array, and I'd like to apply power function here. Power, that means exponential of 2, and our second array will be 1, 2, 3. So after applying power function again, I'd like to show the result. Okay, okay, my original array is 1, A, and this is the B variable. The contents will be 1, 2, 3, and as you see, after applying power function, that means the power of 2, it becomes 100. This is 1,000, 10,000, and this becomes 1 million. And how about a second array? After applying this power function, it becomes 10 and 10,000, and how this 1,000, 10 million, 100 million. Okay. And how about our next? I here define two variables, two arrays, and our first array will be printed out, and the second array. And I'd like to show you here modulo function here, that another saying, dividing with remainder. So initial values, this one, okay. After applying modulo function, I'd like to print out the result, and as you might have familiar about from the previous languages, you could guess applying for the first array, applying only 1, because the remaining dividing by 3, 1, okay. This is divided by without any remaining, okay, 0 remaining, and for 30 divided by 7, 2 is the remaining. Okay, this is the remaining. How about the remainders? remainder, when we say remainder, we get the same results. Just it's up to you. Which one do you want to? Okay. This is our next example. I here define an array including complex numbers, complex elements, and at first I print our original array, and I'd like to show you how to show the real part of these complex numbers, and the keyword real, and for the imaginary part the keyword is image, and after that I can show you conjugate of this complex number. For example, for this one 1 + 1j, the conjugate of this one is 1 - 1j, and let me show you the calculation after that. Okay, this is the real part. Okay, here there is no real part. 0 stands for it, and again there is no real part. The real part is 11, and the real part is 1. And how about imaginary part? After applying image function, imaginary part is 5.6. Just we omit letter J, and imaginary part is 0.2, and imaginary part, there is no imaginary part for this one, and the imaginary part plus 1 without J. Okay, after applying conjugate function, this is the results. Just changing this number -0 plus, this is converted to plus, and this is also converted to -0.2. Okay, just after that we can return it to polar form rather than rectangular form. In order to change it polar again, polar function, we use angle, and this is the angle values. However, they are in radian, and we would like to change it to degrees. Okay, I here define. Okay, this I use this structure. I say degree. Okay, true, and the calculated values will be converted to in degrees format here. Okay, this is the end of these NumPy lessons, you guys. I hope you find it useful. My examples are easy, in fact. However, lesson by lesson, I will make it much more comprehensible, much more sophisticated. But I don't want to accelerate this process, because you have to savor it. You have to memorize completely, keep it in mind, and I'd like to say bye-bye. Thanks for your watching me. Thanks for your time, and up to next time, keep in peace. Bye-bye.